Good morning, everyone. My name's Elizabeth Medford, and this morning I'll be talking about the Clean Distributed Energy Grid Integration Act. Before I begin, I'd like to thank my team for their hard work and dedication, and our faculty advisor, Louise Rosen, for her guidance. Superstorm Sandy hit New York City in 2012, and we heard a bit about it earlier this morning. It was the second most devastating storm in US history, and there were many consequences from this storm. One of which was that 8 million people were without power, and some of those were without power for up to 2 weeks. Now, this is important because many of the services that we depend on a daily basis use electricity to function. This includes drinking water, flushing toilets, access to food, transportation, and hospitalization and medical care, just to name a few. Now, this really reflects the instability of our grid, meaning the infrastructure that we use to move electricity. Here we can see in the picture that some parts of Manhattan were completely without power after the storm, while other parts still had grid power and still other parts had generators on site that kept them with electricity. Now, this is one of the issues that our bill addresses, is the current state of the grid and its instability. The grid is also aging. In some places, it's over 130 years old and was built to service only a few people in a small area. Since then, it's expanded on a national level and now services 140 million customers, with demand continuing to increase. So just in the past decade, we've seen an increase in energy demand by 10%. Not only is our grid old and unstable, it's also inefficient. So looking at the diagram below, we can see that if we start with 100 units of energy, we lose half of that just in the production of electricity. Then we lose another 4% and 2% in distribution and transmission. Now, while this might not seem like a lot of energy loss due to transmission, that results in daily energy losses from transmission that could power 50,000 US homes for a year. So the energy that we lose every day just moving electricity around the country is actually a lot of energy loss. Today I'll be giving an introduction to our bill, some of the proposed solutions described in our bill, measurements of success, and finally our conclusions. So besides the current state of the grid, another issue that our bill is addressing is climate change. And with the example of Superstorm Sandy, we saw one of the major impacts of climate change, which is the increase in intensity of storms like Superstorm Sandy. Other impacts include forest fire, drought, sea level rise, and ocean acidification, just to name a few. Now, climate change is the result of the burning of fossil fuels to produce electricity and other energy needs. When we burn carbon fuels in the presence of oxygen, we produce carbon dioxide and other greenhouse gases. These travel to the outer parts of the atmosphere and act to insulate the planet, preventing outgoing radiation from leaving the atmosphere. Now, this is a good thing. It makes our planet habitable, but we're changing the concentration of these gases above what they would normally be. In addressing the issue of climate change, a good place to focus is the electricity sector. We can see here that electricity accounts for 1/3 of US carbon dioxide emissions. And when we zoom in to figure out why that is, we can see that 71% of these emissions come from coal. So we're using dirty sources of energy to produce electricity. And this is the other issue our bill is addressing. Specifically, our bill aims to encourage clean, integrated, distributed generation of electricity. We can see what this would look like by comparing to now. We see that now we have a conventional power plant going to the grid, the infrastructure of distribution, then an electricity meter, and finally the consumer. We can see that all arrows flow in one direction, meaning energy is flowing from the central power plant to the consumer. We can compare this to the situation that our bill is encouraging, where we have the grid and the meter, but instead electricity is produced using clean, distributed energy sources on the consumer side of the grid. We can also see that arrows are going in both directions, meaning that energy not used by the consumer can go back onto the grid. Aside from being distributed and integrated, our bill aims to encourage clean energy production. Now, clean is defined by another legislation called the Clean Energy Standards Act of 2012. And this defines clean energy as fuels that produce fewer than 0.82 tons of carbon dioxide per megawatt hour. We can see that coal does not fit this definition, while natural gas does and wind and solar energy do. This is important in terms of the political context of our bill as well. We believe that natural gas was included to get support from both sides of this issue and to include those involved in the rising importance of natural gas in our energy mix in the United States. In terms of efficiency, we can see that they're pretty similar and that the lowest efficiency is actually wind and solar. But it's important to keep in mind that since emissions are so much lower with these energy sources, efficiency is not as much of a concern in this case. So specifically, our bill will achieve this goal of encouraging clean, distributed, integrated energy by doing research onto the status of grid integration and barriers to further development, setting up a stakeholder working group to get everyone at the table discussing these issues, distributing grants of $15 million each year for demonstration projects, and these demonstration projects could include combined heat and power plants, fuel cells, waste-to-energy plants, and renewables like wind and solar, and also reporting to Congress with recommendations for new legislation. In terms of visualizing what this bill could achieve, we can compare two different scenarios. In the upper left-hand corner here, we have a conventional coal-fired power plant. We can see that efficiency is 34%, and emissions, again, don't fall within our definition of clean. We see that electricity has to travel many miles to get to the consumer, and it's centralized, meaning that if something happens to this coal-fired power plant, the consumer will not have electricity. We can compare this to the bottom right-hand corner, where we see clean, distributed, integrated energy production. Here we have a combined heat and power plant, where natural gas is used to produce electricity, and then heat normally lost to the environment is trapped to produce additional electricity. This means that efficiency is 75%, and emissions fit within our definition of clean. We can also look at a solar cell on the side of the consumer and see that, again, while efficiency is not better than conventional methods, emissions are significantly lower, meaning that efficiency is not as much of a concern here. We can also see that it's distributed, meaning that if one of these sources of energy were to go down, the consumer would have a backup source of electricity, and this makes the grid more stable. In terms of measuring the success of our bill, we can look at the different provisions of the bill and determine metrics for each of those. So in the top row here, we're looking at the research report, the stakeholder working group, and the recommendations to Congress, and those will be deemed successful if new legislation is in fact passed. In terms of the grants for demonstration projects, we'll look at the specific demonstration projects themselves and determine if they reduce emissions on site, if they increase energy efficiency, and if they're integrated into the grid, increasing grid stability. So in conclusion, electricity generation remains the largest contributor to US carbon dioxide emissions. So in terms of tackling the issue of climate change, this is a great place to focus. Additionally, the infrastructure we're using to generate and distribute electricity is old and inefficient and unstable. So to address these issues, our bill really creates an opportunity to develop cleaner, more efficient, more stable and integrated electricity generation. This will ideally be scaled up on a national level so that we can transform the way that the US produces and transports energy, helping us comply with international agreements aimed at reducing carbon dioxide emissions while also increasing the stability of our grid here. And ideally, this will be scaled up on an international level, meaning that globally we could change the way that we produce and transport energy, making it cleaner, more efficient, and more stable. Here's just one example of what this could look like in implementation. This is a community in Germany called Solar Settlement. They're a zero emissions community. They produce 300% more electricity than they need, which creates profits of $5,000 per household each year. So this is one example of what our bill could look like. Thank you. Any questions?
Thank you, Lizzie, for that presentation. And I was curious, I noted the efficiency disparity between solar and other mechanisms, and I was wondering if your bill within the demonstration projects has room for research and development for the further efficiencies of solar.
Yeah, definitely. So the focus of our bill is actually research and development. It mentions a few different examples of possible demonstration projects, but really the focus is on developing research into how to make these technologies more easily to implement. Great question, thanks.
Hey, Lizzie, great presentation. So I noticed, like, on, get which number slide, but you had, we're comparing coal, natural gas, and I believe solar. And while, the natural gas falls below the threshold line for emissions, there's still, aren't there still bad implications of natural gas, such as, if the natural gas or if the nuclear power plant is to leak, it causes, emissions of methane?
Yeah, definitely. Thank you for bringing that up. So that's one of the controversies that we discussed in terms of our bill. You brought up a few things. First of all, focusing on carbon dioxide is somewhat problematic because you mentioned methane, and there's obviously other greenhouse gases, in some cases more potent greenhouse gases, to be concerned about. Mostly the inclusion of natural gas in the definition of clean is a political move. It's not really necessarily based on the science of emissions. It's mostly to include natural gas in this definition of clean so that political support can be harnessed from the natural gas producers, and that's becoming an increasing part of our energy mix. So we think that it was probably a political tactic mostly. Thanks.
Hi, Liz. So, hi. Question. I saw in one of your slides that you have, again, to follow up with Isaac, actually, as a clean source of energy, you don't have waste to energy as a resource, or municipal solid waste as a clean source of energy. And I know you mentioned it in the next slide. However, I just want to ask if there is your bill, if there is a section that addresses that, because solid waste is a huge potential renewable resource, and I was wondering if your bill addressed that at all.
Yeah, thank you for that question. So our bill lists a few different examples of demonstration projects, but doesn't necessarily restrict what these projects could look like. So it does actually mention waste to energy plants as one example. We chose to focus on combined heat and power in terms of this example, but we could have also looked at just renewables or waste to energy or any of those other examples. So it's pretty broad in terms of what these demonstration projects could be, as long as they fit within that definition of clean and are integrated and distributed, basically.
Hi there. Thank you very much for the presentation.
Thank you.
How much are you using the state renewable portfolio standards that are currently in existence? I think there's 31 states that have an RPS, and that do have a variety of sources: wind, solar, biomass,
Right.
combined heat to power, waste energy, and so forth. Are you using those in your studies and coming up with policy solutions?
Yeah, so that's definitely an important context aspect for our bill. And our bill would ideally help states to meet those renewable portfolio standards. We mentioned also in our report that it depends a lot on which state these projects are implemented in terms of how much of an impact they're going to have. So for example, states that already have a very ambitious RPS and have very ambitious renewables and other cleaner sources of energy, this sort of project would have less of an impact overall. But our bill is really trying to encourage kind of the implementation of this nationwide, but starting with these demonstration projects. But it could definitely help with states meeting their RPS goals, or potentially encouraging to increase those once it's possible. Thank you.
Thanks for the presentation, Lizzie.
Yeah.
One of the major issues with renewables is the issue of intermittency. Does this aim to address that in some way? And if so, how?
Yeah, thanks for bringing that up. So renewables are interesting. They're not explicitly mentioned in our bill, which we believe is also a political move, but I think that's also part of it, because this bill is about stabilizing our grid, so really having sources that are pretty constant and consistent intermixed with those renewable sources. So the idea is kind of to have many layers of backup and reinforcement, so that if the sun isn't shining, the wind isn't blowing, you have a combined heat and power plant or some other source of energy that can supplement that. Thanks.
Great presentation. So the United States is broken up into several power grids that overlap with multiple states. For the implementation of this bill, do you foresee that as a problem or part of the solution, that multiple states will have to come together to agree on certain issues?
Yeah, that's a great question. Our bill is mainly a preliminary step in terms of encouraging the implementation of these technologies. So we haven't looked yet into what the implementation in different areas of the country would really result in. But I would see that as more of a good thing in terms of implementing these technologies, because that allows different states to work together and kind of create a larger, in terms of talking about RPS or some other like emission standards programs, oftentimes states can work together to kind of make that more economically feasible while meeting emission standards. So I could see that helping with the implementation of this technology. But that's definitely something that we'll be looking into further.
Thank you very much.